Okay, so now we're going to graph our piecewise functions, which I hinted at in the last problem. The key to doing these is that you're essentially going to be graphing 2 or possibly 3 lines on the same graph. So these can be a little time consuming because, hopefully you remember, in order to graph a function you need at least 3 points. So we need to find at least 3 points for each one of these functions that's listed here. It's, again, somewhat arbitrary what points you pick, but what I highly recommend is that for each one, you should figure out what's going on at this boundary here. Now again, what this function is telling us is that if our x value is less than 2, we should use this graph. If it is greater than 2, we should use this one. Greater than or equal to 2, I'm sorry, excuse me. But regardless of where the inequality sign is, for each graph you should definitely use this point, or the boundary points, as it were. You may have some that it falls between a range of values. For example, x might be between 1 and 2, and you'd want to see what's going on at both end points of that graph. So I definitely want to use 2, and then 2 other points, which is arbitrary, so I'll say 0 and -2. Why not? All right, so, and again, I've written them in reverse order like that because I like to go from the smallest x value to the largest. But again, that's arbitrary, that's totally up to you. So now I'm just going to take these values for x that I've picked, plug them in to my first function here. So I have 4 minus -2, which gives me 4 plus 2, which of course equals 6. So I have a point on this graph at -2, 6. And I do it again for 0, 4 minus 0. That, of course, is 4, so I have a point at 0, 4. And again, do it one more time for 2, 4 minus 2, and that equals 2. Now, some of you may be going, wait, but this graph doesn't include 2. That's right, it doesn't. So, when I go to graph these points, all right, -2, 6, which is, these numbers are hard to read on here. I think that's 6 right there. That one I'm going to put a little closed dot, because it's included. Then I have another one at 0, 4, so 0, 4. Now the trick, this last one, I have a point at 2, 2, but it's not actually on this graph, again, because this does not have that equal sign. X cannot actually equal 2, but it can get pretty darn close. So, instead of putting a closed dot there, I'm going to put an open dot, so that I know that for this graph, which you can see that is a straight line, and I'm going to attempt to draw a straight line. I'm horrible at drawing lines or drawing on graphs. So, and then that line extends off in this direction, because again, x can be anything less than 2, so it could continue off in that direction. All right, so that's the first part of my piecewise graph. Now I have to do it again for the other half of the function. So again, I want to know what's going on at 2 for sure. And then I need to pick 2 more values where x is greater than 2. So I'm going to say, again, this is arbitrary, 4 and 6. You could pick anything as long as it's greater than 2. You might have a hard time graphing it if you pick like 52 for x, but that's up to you. That's your choice. So I'm going to plug in these values I've picked for x into this second line, the second equation here. So I've got 1 plus 2 times 2, which of course is 1 plus 4, or 5. So I have a point at 2, 5. And I'm going to do it again for 4. So I've got 1 plus 2 times 4, or 1 plus 8. There's another point at 9, and this last one may not actually fit on my graph, so we'll just have to imagine. But then I have 1 at 1 plus 2 times 6, which of course is 1 plus 12. Oops, I forgot to write this 9 in here. My apologies. So I have 3 points on this graph at 2, 5, 4, 9, and then 6, 13. So the difference is, for this graph, this value for our first point here is included because this one has the equal sign. X can equal 2. So for this one, I'm going to put a closed dot at 2, 5. Start at 2, 5. and then I have another one at 4, 9, and then the third one I'm going to draw in, even though it doesn't quite fit on my graph, but there would be another one at 6, and then we'll imagine it's up here somewhere. Alright, so now again, the trick to these is to realize where the graph stops and starts. So again, for this first one, I stop here because x can't go any higher than 2 for that first function. For this second one, x is everything bigger, but it can't be anything smaller than 2. So the line doesn't extend this way, it just starts here and goes up. And again, I'm a horrible drawer, so I apologize. Okay, so again, should be very clearly a closed dot at that point and an open dot at this point. Please let me know if you have any questions.